Hi, and welcome to the videos for section 10.6. This is the first of 3 videos. In section 10.6, oops, not 2, 10.6, we're looking at what's known as determinants, which we saw a little bit of in the videos for 10.5, and also something known as Cramer's rule. So, remember from the videos in 10.5 when we talked about the determinant of a 2x2 matrix. So if I have A is equal to A, B, C, D, if that's its elements, then the determinant of A, which we also write as the name of the matrix inside what looks like absolute value bars. But if we're talking about matrices, this is no longer the absolute value of A. This is our indication of the determinant of A. And this is simply, as we saw before, A times D minus B times C. So for example, if I want to evaluate the determinant of A for A equals 6, -3, 2, 3, well, that would be what? That is 6 times 3 minus, and so be careful with your signs here, -3 times 2. So that's 18, -3 times, let's do it this way. -3 times 2 is -6, minus a -6 is +6, which means the determinant of A would be 24. So just like when we were doing inverses, 2x2 matrices are nice. N by N, we don't have quite the nice little formula and shortcuts. We have to do a longer process. So let's see how we do that. So determinants of N by N matrices. So I'm going to give you a heads up here. I'm going to start getting into some definitions and some notation that the verbiage and the wording of it, you know, like other stuff we've seen in math, sometimes it's like, what is this guy talking about? And then you see it put into practice, it's like, oh, well that makes sense. Kind of like when we're multiplying matrices. It's like, you know, row I, column J, multiplying it, adding it, it's like, this doesn't make sense, and then you see it done, it's like, oh, well that's pretty straightforward. Similar idea with the determinants. Going to give you some definition, give you some notation. Hang with me, copy it down in your notes, kind of just take it in a general sense, and then we'll see it put into practice, which will hopefully make it more sense to you at that time. So definitions, minors, and cofactors. And so I'm not trying to say this is difficult, it's just that the verbiage can be a little confusing, and that's, I just want to give you that heads up so that if, as you were going through this, you feel confused, don't worry, it'll clear up for you. So first, the minor, so because of minor we're calling it M, Ij, of the element Aij is the determinant of the matrix found by deleting the ith row and jth column. So if we're talking about minors, that's what we're talking about, basically a minor matrix. So we pick one element, eliminate that column and that row, and all the other pieces left are the minor matrix. And then 2, the cofactor capital Aij of the element Aij is as follows. So Aij is equal to -1 to the I plus j power times the minor matrix Ij. So again, I know it's probably like, what is this guy talking about? That's okay. First time I went through it, even now as I write it, I really have to think through what's going on. But as we start putting this into practice, the I's and the J's start getting numbers, the M's start getting numbers, the cofactor starts becoming a number, and now that we start dealing with numbers, it tends to make it easier on people. So let's look at an example. Let's say let A equal the matrix 2, 3, -1, 0, 2, 4, -2, 5, 6. So if I want to find A12 and find A33. So, first thing I need to find A12 is the minor matrix 1, 2. And that means what? That means I cross off row 1 and column 2. So M12 is just what's left, 0, -2, 4, and 6. So I want M12, I cross off row 1, column 2, and when I do that, what's left over? So that's the matrix. So now I want the determinant of this guy, because that's what the minor Mij of that element is, the determinant found when I delete that. So if I want the determinant then, this is going to be what? So the determinant essentially, well, M12 is a determinant. So I want the determinant of this matrix. Now that it's 2 by 2, I can do what? 6 times 0 minus 4 times -2. 4 times -2 is -8. 6 times 0 is 0, so 0 plus 8 is 8. So M12 is equal to 8. Now, A12, if I use the formula, is -1 to the I plus j power, 1 plus 2, times M12. So this is what? This is -1 to the third times 8. -1 to the third is -1. -1 times 8 means this is -8. So A12 is just -8. So how about A33? So go ahead, I get it, you just learned it, but try to figure out 3, 3. So what are we going to do? We're going to cross off row 3 with column 3 and then do the work from there. So go ahead, hit pause if you want, give it a try, come on back, let's see what you got for an answer. All right, hopefully you gave it a shot. So first thing we need is M33. So if I cross off row 3, column 3, That gives me what? That gives me the matrix 2, 3, 0, 2. So the determinant of that is 2 times 2, which is 4. Well, so let's do this. 2 times 2 minus 3 times 0. So this is 4 minus 0, which is 4. Now, A33 is equal to negative 1 to the 3 plus 3 power times positive 4. It's negative 1 to the 6th times 4. Negative 1 to the 6th power, because it's a negative in even number of times, is going to be positive 1 times 4. Positive 1 times 4 is 4. So, that's how we figure out minors and cofactors. Using that, we can then find determinants in the following way. So the determinant of an n by n matrix is found by multiplying the element of the first row say the elements, multiply the elements of the first row by its cofactor and adding the results. Okay, so what this means is the determinant of some matrix A, so the determinant of A is the determinant of A11, A12, etc., all the way up to A1n. And then this is what? A21, 22, etc., all the way down to n. So AN1, all the way over to ANN. That's a general form. So this determinant is going to be A11 times the cofactor A11 plus A12 times cofactor A12. And you do this for the whole row. And technically, I guess we're going to see it here in a bit, but we'll find out it doesn't just have to be the first row. We can pick and choose whatever row, whatever column we want, but the key is we keep adding these pieces up. So A13, A13, all the way up to A1n, A1n. So that gives us the determinant of an n by n matrix. So we have another note here, and something to make math a little bit easier on us. So note, because Aij is found using -1 to the I plus j power, we get either a +1 or -1, depending if I plus j is even or odd. So if I plus j is odd, get a negative 1. I plus j is even, always get a positive 1. So we can create a matrix on that. So row 1, column 1 is what? 1, 1. 1 plus 1 is 2. Because 2 is even, negative 1 to the second power, we're going to get a plus 1. Row 1, column 2, that's odd, so negative. Row 1, column 3, that's 4, that's positive. Negative, positive, negative, etc. Keeps on going, alternating. What about going down? Well, this is what? Row 2, column 1. 2 plus 1 is 3, that's odd, it's going to be negative. 2 and 2, even, positive, negative, positive, negative, positive, etc. And this thing is just going to keep alternating as it goes. All the way to the end, no matter how big your matrix is. So, using kind of all this information we just learned about, numbers we generated, let's try to do an example. So I'm not going to hit pause, I'm going to erase this. If you need it, hit pause. Alright, so we have the following example. Let's find the determinant of A if the matrix A is 2, 3, negative 1, 0, 2, 4, negative 2, 5, 6. So, a couple things I like to do here. Remember back to that plus minus matrix. So let's do that. We always start with plus and then minus, plus, minus, plus, minus, plus, minus, plus. That's essentially how the pluses and minuses would work for this 3 by 3 matrix. Now, to do the determinant, I'm going to do what? A11, cross out the rows and columns associated with that guy. What's the determinant of what's left? And then the second value in the first row, third value. So these guys, the plus and minuses, those aren't going to affect the problem here, so I'll erase them so I don't get you confused. But we have what? We have positive 2. And then if I block off the first row and the first column, what am I left with? 2, 4, 5, 6. Then what's next? Minus 3. And this minus comes from my plus-minus matrix. Otherwise, I'd have to keep calculating this. Negative 1 to what power? Negative 1 to what power? But I don't have to do that. I know that it's just going to alternate from positive, minus, etc. So it's the negative 3. If I cross off the first row in the middle column, I get what? 0, 4, negative 2, 6. And then last, plus a minus 1. Cross off the row and column associated with that value, so I get 0, 2, negative 2, 5. Now I have these 2 by 2 determinants that I can use the formula on. So I have what? 2 times, 6 times 2 is 12, minus 4 times 5, which is 20. So there is a lot of minus signs when we're calculating determinants, so I'm going to stress it to you. Be careful with the signs, because as soon as one of these signs gets off, the whole rest of the problem's in big trouble. So then I have what? Negative 3 times 0 times 6 is 0, minus 4 times negative 2 is negative 8. Minus 1 times 0 times 5 is 0, minus 2 times negative 2 is negative 4. So now simplify. You get 2 times 12 minus 20, negative 8. Minus 3 times 0 minus a negative 8 is like plus 8. Minus 1 times 0 minus negative 4 is plus 4. 2 times negative 8 is negative 16. Negative 3 times 8 is negative 24. Negative 1 times 4 is negative 4. So negative 16 minus 24 is negative 40. Minus 4 means the determinant of that matrix is negative 44. So, as I kind of stumbled along when I was giving you the definition, and then I wrote it out, and then I told you later, we don't necessarily have to just do the first row. The determinant can be calculated with any row or even any column. So let's try to show that. Let's do this same example, but instead of using the first row, let's try to make life easy on ourselves. Well, this row has a 0, right? So the more zeros that we can get, the easier it's going to be because some of these guys are going to fall out to be 0. So let's use the second row, but because I'm using that second row, I need to keep continuing this plus minus matrix. So now I'm using the second row for my work. So I have what? I have negative 0 times some determinant. I really don't care, right? Because 0 times anything is going to be 0. Then plus 2. So if I'm on this middle, it means what? Middle column, middle row. So I get what left over? 2, negative 1, negative 2, 6. You have to be careful there too. If I'm on this value, it's that column and that row associated with it. And then last, minus 4. And that's why that plus minus matrix is so important. So minus 4. Now I'm not looking at the second row or the last column. So I get 2. So don't worry about these plus and minuses now. That was for our plus minus matrix. So 2, 3, negative 2, 5. 2, 3, negative 2, 5. So let's calculate this. Again, this guy is 0. That's why I want to have as many zeros in my rows or columns as possible. Make life easy. Plus 2 times. 2 times 6 is 12 minus negative 1 times negative 2 is positive 2. Then minus 4. 2 times 5 is 10 minus 3 times negative 2 is negative 6. So minus a negative 6. Simplify this, we get what? 2 times 12 minus 2 is 10. Minus 4 times 10 minus a negative 6 is like 10 plus 6, which is 16. Positive 16. So we get what? 2 times 10, 20. Minus 4 times 16 is 64. 20 minus 64, lo and behold, negative 44, the same value that we got when we did it off of row 1. And no matter what row, no matter what column you do your determinant math off of, you're going to get the same values. So that's it. That wraps up video 1. I know it was a little longer than most of the videos I put you guys through, but kind of wanted to keep all of that together because it all ties together and I didn't want you having to go from one video to the next to get the information. So come on back and we'll look at video 2.